we have the 4 chapters generally. The first one is chemical equations and reactions. Okay, if I talk about the chemistry, so we have 4 chapters. Okay, first chapter is chemical equation and reaction. The second chapter is acid, bases, and salts. Third chapter is metals and non-metals. Okay, and the fourth chapter is carbon and its compound. Okay, if I talk about this first chapter is the basics of the other 3 chapters. Okay, means if you are not able to understood this chapter, means if you are having problem in chemical equations and reaction, then this chapter and this chapter you will not be able to understood. And most probably, if these 2 chapters are not able to understood, you will not be able to understood the carbonates compound. So I can simply say that like some chapters are independent on one another. Like for example, in biology, if you study the reproduction chapter, and if you didn't study the carbonates compound, then reproduction chapter you will will means you there is no need to study the carbonates compound chapter and the reproduction. Okay, because this is biology and this is chemistry. In fact, if I talk about the same, like in reproduction and chemical or we can say that control and coordination or nutrition. So nutrition in biology, the one chapter is not interconnected with another, but in chemistry, one chapter, your first chapter is interconnected with the another chapters. So if you didn't get or if you are not able to understood this chemical equations and reactions, then probably you will not be able to understood the acid bases and salts and metals and non-metals. Okay, understood? So
Yes, sir.
we can say that still if this chapter carries if we have in chemistry, like we have 30 marks of chemistry, okay, or 27 marks or whatever. So if you don't think that if this chapter is carrying 6 marks or 7 marks, no, this chapter is actually interconnected. So if this chapter you are not able to understood properly, then other chapter will not be able to understand, means you will not be able to score in this chapter. So this chapter is very important for studying the other chapters. Okay, so let's start. So first of all, in the chemical equations and reactions, chemical, okay, chemical equations and reactions. The first word come chemical. What do you mean by the word chemical? There are 2 words that we generally have when a change is going to take place. Change. There are 2 types of change. One is the chemical change. You are very much familiar. Chemical change. And the second one is physical change. Second one is physical change. Okay, are you getting this one?
Yes, sir.
When a chemical change is done and you write it in the form in terms of symbols and formula, okay, then we considered it as chemical change. Means writing a chemical change in terms of symbols and formula, we considered it as chemical equation. So what is the definition of chemical equation? What is chemical equation? Chemical equation. So we can simply say here that writing a chemical change in terms of symbol and formula is called chemical equation. It's called chemical equation. Okay, you understood? So when you write a chemical change in terms of symbols and formula, okay, a chemical change in terms of symbols and formula is called chemical equation. Please note it down, the definition. When you're done, please let me know. The question come, what is chemical change? Can you tell me what is chemical change?
When the symbol of formula changes.
When when a new substance is formed with new properties, new chemical properties.
Yeah, very good, very good. So if I simply say that what is a chemical change? So chemical change is, we can simply say that the change in which a new substance is formed, having entirely different chemical properties from its constituents. Okay, we called it. What's the name of that third student named as Zoom user?
Sir, I'm Mariam.
Mariam, how are you?
Fine, sir. How are you?
I'm also fine. Mariam, we are just studying the first chapter of chemistry. Okay, and just started recently. So just
Okay,
concentrate.
sir.
Okay.
Okay,
So
sir.
if I write that, what is a chemical change? For example, if I'm having, if you are having like hydrogen gas, H2, hydrogen gas, and it burns in open air. Okay, open air. Then you will get water, H2O. Okay, we're just going to balance it. Okay, we'll learn how to balance, but first concentrate here. This is hydrogen gas. Hydrogen gas. This is oxygen gas. Okay, and this is water. Okay, this is gas. This is also gas. And this is liquid. You know that this is hydrogen gas. Okay, this is oxygen gas and this is water. They, you know that hydrogen gas act as a, tell me, fuel. It is a fuel. Okay, everyone know that it is a fuel. Okay, hydrogens is used nowadays, recently used in as a in car. Okay, and it is also used in the rocket engines. So it act as a fuel. Oxygen, what is the function of oxygen? It help in combustion. Okay, as you know very well that oxygen help in combustion. Okay, so help in combustion, help in combustion. Okay, but can you tell me that what is the function and what does water do in case of fire? What does water do in case of fires? Water actually extinguish fire. Okay, it extinguish fire, you know. So here you see that this hydrogen gas and oxygen gas, when they are chemically combined together, they form a substance called water, which is not having the properties of its constituents. Like you see that in the water, hydrogen is not showing its property of hydrogen gas and oxygen is not showing its property of oxygen gas. They both combine together and they are forming a new substance which is not having the properties of its constituents. So this type of change is called chemical change. You understood? Tell me fast. Understood? So
Yeah.
what is a chemical change? What is a chemical change? The change in which a new substance is formed, having entirely different chemical properties from its constituent, means from which it is made up of, it is not showing the properties of its constituents. Okay, in water, the water does not show the property. Otherwise, water will burn more efficiently because water is having hydrogen which burns and oxygen combined togetherly. It must burn. It must burn at the very, mean instantly. It must be very flammable, but it does not happens like so. Okay. So if I talk about that, what is a chemical change? So the chemical change is the change in which a new substance is formed. Okay. Chemical change is a change in which a new substance is formed having entirely different chemical properties from its constituents. Okay. So we say the change in which a new substance is formed having entirely different chemical properties. Having entirely different chemical properties from its constituents. Okay, please note it down. Having entirely different chemical properties from its constituents. Like, for example, burning of hydrogen gas result in the formation of water. Burning of hydrogen gas results in the formation of water. Okay, so note it down, please. Okay, done. Noted,
sir.
everybody?
Yes, sir.
Yes, Gianna, how are you? What's your name? Gianna?
Yes, sir.
Gianna, is it your first class with us?
Yeah.
Means you were not the previously 9th standard student, na, with us?
No, sir.
Okay, Gianna, we are just studying the 10th standard first chapter, chemical equations and reaction of chemistry. And in this chapter, we are just studying the basics of chemistry, that what we are going to study in this chapter. And firstly, we are just studying the chemical equation, that what is chemical equation. So when we write a chemical change in terms of symbols and formula, okay? When we write a chemical change in terms of symbols and formula, like for example, if I told you that hydrogen gas is burned, so this is a chemical change. Okay, burning of hydrogen gas is a chemical change. But if you write it, if you are able to write this hydrogen like this H2, it is a symbol of hydrogen gas, a symbol of oxygen gas, and water, which is the symbols of or formula of water. So if we write the chemical change in terms of symbols and formula, okay, this is called chemical equation. This is called chemical equation. Understood? So we are just currently studying that what is actually the chemical equation. Okay, so chemical equation is writing a chemical change. Now we are studying the what is chemical change, actually the difference, actual difference between the chemical change and the physical change. Okay, now if I talk about the physical change, what is physical change? Can anybody in the class tell me what is physical change?
When no
When
new
there's
Yeah,
subs
when a new substance is formed.
when there's no new substance formed.
No new substance is formed. For example, if I took a glass of water, okay, and I dissolve some water to it. Sorry, and what take some water and dissolve some salt to it. Okay, and if I ask you to drink it, how will you feel the taste of this one? Will it be salty or sweet?
Sorry.
Salty. Okay, now if I ask you to add some sugar to it, how will be the taste? It will be both salty as well as sweet, showing the taste of both salt as well as sugar. Okay, and if I ask you to add some lemon to it, so lemon, when you add some lemon to it, so it will give some sour taste. So when you are having this, means you are just preparing this mixture. So in this mixture, you are going to have this salt taste, that is salty, the sugar, the sweet taste, and the lemon, the sour taste. All the constituents are showing their property even after mixing. Okay. So if the constituents start showing their property or keep on showing their property after the change also, so we will consider it as a physical change. Okay. So this will form a laminate, and this is considered to be as a physical change, because here you see that it is not going to have, means we will simply say here that in a chemical change, the constituent is formed, but in physical change, the constituent, the new constituent is formed or new substance is formed, but in this one, no new substance is formed. Still, we will say that lemonade is formed, which is a new substance, but still the constituent show their property. Still the constant. So actually we will say that it is not it in terms of science, we will say that lemonade is found is a different thing than the water, than the sugar, than the salt and the lemon. But in the terms of chemistry, it is, we will say that no new substance is found, because in chemistry the new substance means that it must not show the property of the constituent. If it is showing the property of the constituent, then it means that it is still a physical change and no new substance is found. Okay, everybody understood in the class?
Yes.
Yeah.
Is there anyone who didn't get this one? So what is physical change? Physical change. The change in which? Change in which? In which no new substance is formed. The change in which no new substance is formed, and the constituent still shows their property. The change in which no new substance is formed and the constant still show their property, that is called physical change. For example, tearing of paper. Tearing of paper, mixing of salt in water. Okay, actually, when a physical change is formed, then we will simply say that the substance that is going to form, it is not going to have a particular formula. When you dissolve some salt in water, it is not going to have its formula. Means the solution of salt and water is called brine. We called it brine. Okay, but brine don't have any formula. Don't have any formula. You understood, everybody in the class? They don't have the formula. So whenever a chemical change is going to form, then it is going to have some formula. Then it is going to have some formula. Have you noted this one, everybody in the class?
Yes.
Yes, sir.
Yes, Mariam, you understood?
Yes, sir.
And you, Gianna? Gianna, you there?
Yes, sir.
You understood?
Yeah, yes, sir.
Okay. So now coming to the point here, that what is a chemical equation? Writing a chemical change in terms of symbols and formula is called chemical equation. Okay, so let's have one or two questions over it, and then we shall be moving further. Just a minute. Tell me which of the following is the correct option. Which of the following is not a chemical change?
The physical change.
which of the following is not a physical change? Means indirectly asking for the chemical change. Tell me, what's the answer?
Combustion of liquefied petroleum gas.
Yes. Combustion of liquefied petroleum gas. Liquefied petroleum gas has particular formula, and whenever something is combustion, means burning, so it is generally converting into carbon dioxide and water. For example, this is C4H10. That is the formula that you will learn, and this is the formula for the LPG, liquefied petroleum gas. LPG has formula, and when you burn it in the presence of oxygen, then it will gives you carbon dioxide plus water. Balancing we will do it later, but it will gives you carbon dioxide and water. And carbon dioxide is not combustible. It is combustible, but carbon dioxide is not, and water is not combustible. So we will say that these two substances are formed, which is having a new property, not showing the property of the LPG and oxygen gas. Okay. Can you tell me that what is the reason behind that the substance, when they are forming a compound, they actually does not show the property of the constant? Why they don't show the property of the constant? So let's study, because you have studied this one in the 9th standard. So let's study topic that why in a chemical change, why in a chemical change, the constituent do not show their property. Okay. Why in a chemical change, the constituent do not show their property. Got it? So if I ask you this one, that why it does not happen? So it is just because of the electron exchange. Let me explain you. That you are very much familiar that this is nitrogen, because you have studied nitrogen, oxygen, hydrogen in the 9th standard. And you know that the hydrogen, nitrogen gas, oxygen gas, they are going to have atomic number 1. They are going to have atomic number 7, nitrogen, and oxygen is going to have atomic number 8. If you don't know, so let me explain you that they have their atomic number this one. And you know that the electronic configuration of hydrogen is 1, that of nitrogen is 2,5, and that of oxygen is 2,6. Now compare to the atom of this hydrogen. Hydrogen atom is like this. Oxygen atom is, nitrogen atom is like this. 2 in the first shell, 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6. There's a 6 electron in the oxygen atom. Now you know that nitrogen is 78% in the atmosphere, and you cannot inhale the nitrogen. If you are given the nitrogen cylinder, then you cannot utilize it as a gas for the lifeline. We can say that lifeline gas. It is not, oxygen is the lifeline gas, but nitrogen is not that one. You cannot survive without oxygen. Just because of 1 electron difference in the atom, you can see here that they are having entirely different chemical properties. They are showing different chemical properties. Okay, understood? Just because of electron difference. Just here it is 5, here it is 6. 1 electron difference in the atom of the oxygen and nitrogen, making it entirely different. Like for example, if you have 2,4 electrons like this one. So if it is only 4 electron, then it will become carbon atom, 2,4, and it will not show the property of either of nitrogen, oxygen. It will show the property of carbon. So just because if you enter, so for example, if you remove 1 electron from the oxygen and enter it into the nitrogen, suppose, or from where somewhere else also, if you add 1 extra electron to the nitrogen atom, then it will have 6 electron, 2,6, and it will start behaving the property of oxygen, not the nitrogen. So it is the number of electrons that are responsible for showing the property of an element. Okay. And if the change in the electrons take place, this substance. Okay, just a minute. Let me. There is noise. Now you can see that it is just because of a single extra, means just because of an extra electron in oxygen atom, the oxygen shows different property than that of nitrogen. We can inhale the oxygen and it make us survive. Okay, but he cannot survive with the nitrogen gas. So it is the number of electron of an atom that is making it different. Okay, now what happens when the hydrogen atom is going to combine? Let me explain you. That this is two hydrogen atom. One hydrogen atom is this one. This another hydrogen atom is this one. They are combining together. What happens when hydrogen gas is burning? This is the two hydrogen atom and they are combining together. That's why it is called H2. Hydrogen does not independently exist. They are just sharing their electrons. And you know the concept of in the chemistry that, first of all, let me explain you that what is chemistry. In chemistry, we are just going to study about the chemical change and the stability of the compounds. Chemistry is just about the stability of the compound, that why this compound is formed. It just in order to make it itself stable. The compounds are formed in chemistry. Why water is stable? Why water does not change to some other form? Because water is stable compound. How it is? We will learn it slowly. We will learn. But you know that why they are the combining together? Because you know that hydrogen wants to have the electronic configuration to the nearest noble gas, and that is helium. Okay, that is helium. And helium has how many electron in the outermost shell? Can anybody in the class tell me? Can anybody in the class tell me that how many electrons are there in the helium? Helium has 2 electrons. Okay, 2 electrons. This is helium, and helium is a noble gas. Another one is neon. Neon has 2,8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, neon. So every element wants to have the electronic configuration to the nearest noble gas. Like hydrogen want to become like the helium. It wants to have 2. So the 2 hydrogen atoms, one this one and one this one, they will combine together and then will form hydrogen molecule H2. Hydrogen atom does not independently exist. It exists in the form of H2. Why it exists? Because it wants to be stable. One time this electron is going to revolve in this orbit, it will become stable, and one time it will revolve in this one, and they both will become stable. So they combine together and they will have the nearest noble gas electronic configuration, that of helium. And similarly, oxygen. One oxygen atom is oxygen also exists in the form of O2. Okay, O2. Just concentrate here, that this will help you to understand the concept that what is chemistry actually about. Okay. So they are the one and they are the 2 oxygen atom. 1, 2, 3, 4, 5, 6. Okay. And here is another oxygen atom. 1, 1, 2, 3, 4, 5, 6. Okay. Now, oxygen also does not exist in its individual form. It exists in the form of O2. O2. Why O2? Because oxygen has 6 electrons in its outermost shell. 1, 2, 3, 4, 5, 6. And it want to have the nearest noble gas electronic configuration as that of neon. So it will combine with another oxygen atom. Okay, dear students, it will combine with another oxygen atoms and will share 2 electrons. 1, 2, 3, 4, 5, 6. So when these 2 electrons revolve in this orbit, it will have 8. And with any of this 2 electron of this atom revolve in this orbit, it will have 8. So they both combine together and they share 2 electrons. That's why it forms O2. What it forms? O2, oxygen gas. Okay, in order to attain this stability. Now you know that when they are just going to combine, they will form water. When they combine together, they will form, when oxygen gas and hydrogen gas, they are just combining together. This is oxygen gas. And when they combine together, they will form of water. So there are 2 hydrogen atoms. This is 1 hydrogen atom. This is 1 oxygen atom. 1, 2, 3, 4, 5, 6. And this is, okay. Now, you know that this is the 2 in the first shell and 6 in the outermost shell. Now just concentrate here, dear students, this is very important. Now this one hydrogen atom will share one of its electron with this one. And this one oxygen atom will share one of its electron with this one. Okay. And they will form H2O. H2, the two hydrogen atoms and one oxygen atoms. Okay. Now you know that when this electron come in this orbit, it will become stable because it is sharing. Sharing electron means that this is not only participating in this oxygen atom, it is also participating in this hydrogen atom also. This electron is not only participating here in the hydrogen atom, it is also participating in this oxygen. So now you know, you can say that if you count 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen will become stable because of 8 electrons. And similarly, dear students, similarly, this hydrogen atom will also get stable with this 1, 2, 1 and 2. They are going to have duplet. Hydrogen wants to have helium electronic configuration. And you know that in a chemical compounds, the atoms are combined together. Okay, in a chemical compounds, atoms are combined together in a fixed ratio. In water, only the two hydrogen atom can combine together. It cannot combine. We cannot have formula like H3O. Why? Because there is no space for the third electron. Like you see here, oxygen has how many electrons? 6. 2, 6. Now it required two electron to complete this octet. So one hydrogen atom will give 1 electron, another hydrogen atom will give 1 electron. So it will become 2, 8. It cannot have 9. It will become unstable. If you have one hydrogen atom extra, then it will become 2, 9, which is not possible. Yet 2, 8, 1, which is not having the electronic configuration of the nearest noble gas or the noble gas. So every atom wants to become stable in the chemistry, that what we are just studying today, and we are just keep on studying in chemistry. It is just because of the stability of the atom. So in a chemical compounds, now you can see that the atoms combine together in a fixed ratio. Every time the two hydrogen atoms and one oxygen atom will combine together, and they will form water. They will form one molecule of water. This is one molecule of water. One molecule of water. Now you understood, dear students? You cannot combine 3 oxygen atom. You cannot combine the 3 hydrogen atom with 1 oxygen atom. You cannot combine. You cannot even though you cannot combine 1 hydrogen atom and 1 oxygen atom. 1 oxygen atom required 2, so it means required 2 electron. Got it? Got it?
Yes,
So
sir.
that's why, let me explain you that you know that you are very much familiar that calcium when form calcium oxide, you are very much familiar that calcium oxide has formula C. Calcium has 2 valency, oxygen has 2 valency. We write it like this way. But why it is always having valence CaO? Why not Ca2O like Na2O? Why it is not so? Because you know calcium has electronic configuration 282 and oxygen has electronic configuration 2, 6. So this 2 electron, when it donate to this one, it will become 288 and it will become 28. It is the electronic configuration of the nearest noble gas, that is neon, and it is the stable electronic configuration that of argon. So every calcium atom can donate 2 electron and every oxygen atom can accept the 2 electron. So if it is donating the 2, it will make the formula C, 1 calcium, 1 oxygen. But if the donator is 1 only, but oxygen required 2 electrons to complete its octet. And if the donator is 1, like in sodium, sodium it has electronic configuration 281. Okay, and oxygen has electronic configuration 2, 6. So if sodium can donate 1 electron, because when it donate 1, so it will have 28. So when it donate 1, the oxygen will get 2, 7. Still it is not having this electronic configuration, stable electronic configuration to the nearest noble gas as that of neon, 2, 8. So it will require 1 extra sodium, 1 more sodium. So 1 more sodium when come, it will have 281, and this will also donate 1 of its electron, that will form 28. So the formula means 2 sodium atom will be required for 1 oxygen atom to combine. The formula will be Na2O. Understood? Understood. That's why in a chemical compounds, elements combine together in a fixed ratio. Fixed ratio. Always, if you are having the water, irrespective, it is of the ocean water, it is of the pond water, or sea water, lake water, river water, any underground water, anywhere. If it is from London, USA, America, anywhere. Okay. If you are just saying that it is water, even if it is found on the another planet, it must have H2O. The formula should be same. We cannot say that the water of the USA or water of the moon will have different formula. No, it will have the same formula. So the chemical compounds have fixed formula and they are combined together in a fixed ratio because they are just combining together in a chemical compound. Actually, the electron are participating. Chemical reaction is taking place. Bonds are broken and new bonds are formed. But what happened in the physical change? Like you see here, dear students, this is water. Water, you know that water molecules are like this. Just I'm making water molecules like this. These are the water molecules, and you know that in the 9th standard you have studied that atoms, the characteristics of matter, that matters have space between them. So when you keep on dissolving, like you are dissolving salt to it, so salt crystal will comes in the intermolecular space of this one. They are not breaking the bonds of the water molecule. They are not breaking. They are just coming in the intermolecular space. When all the intermolecular space get filled, the solution will become saturated and no more salt can be added to it. So this is actually coming in this is a physical change, and it can be easily separated by using physical methods like boiling, evaporation, condensation, okay, sublimations, decantations. So they can be separated out by different physical methods. But can you able to separate the hydrogen gas from the water just by heating it? No, it will change into the vapor state, but it will not, because the bonds are formed. The bonds are tightly formed and they are just exchange of electrons. Now you can see here, just when water molecule is formed, I'm just going to explain you with the structure of the water molecule. This is the water, this is oxygen atom. Okay, dear students, that this is the oxygen atom. Only I'm just representing the intermolecular, only the outermost shell's electron, because the inner electron does not participate. So oxygen has 6 electrons in its outermost shell. Okay. So oxygen has 6 electrons. So just representing the 6 electron of the outermost shell of oxygen. Okay. And hydrogen has only 1 electron in its outermost shell. It has only 1 shell. So this is the 1 electron. So they combine together, it would form 2 hydrogen. We will simply say that duplet of the hydrogen is completed. Here it is also completed. Okay. And here the octet of oxygen is also completed. Octet of oxygen atom is also completed. Oxygen is going to have 1, 2, 3, 4, 5, 6, 7, 8. Now you know that since the exchange of electron is taking place and the electrons are being exchanged, electron is jumping from here to here and here to here. So how can a substance can show its property? You know that oxygen atoms and the nitrogen atom only has 1 electron difference. It is going to have 1, 2, 3, 4, 5 electrons, and it is going to have 1, 2, 3, 4, 5, 6 electrons. So if the exchange of electron is taking place, if you just transfer 1 extra electron to this nitrogen atom, it will start behaving like oxygen. If you remove the 2 electrons from this one electron from this oxygen, so from this nitrogen, it will showing the property of carbon, that is going to have 2, 4 instead of 2, 5. If you remove 1, it will become 2, 4 and will show the property of carbon. So it is the electron that are responsible for showing the chemical properties of the atoms. Okay. You will learn that it is only the outermost shell electron. It is the only outermost shell electron that are responsible, because the outermost shell electron participate. So you will learn that lithium, sodium, potassium, okay, like you see the electronic configuration 2, 1, 281, 2881, 19 atomic number of so potassium is 19, sodium is 11, and lithium is 3. So they are all going to have 1 electron in their outermost shell. So they are almost having the same chemical properties. So it is the outermost shell electron that participate in the chemical bond and are responsible for the chemical properties of an atom. Understood, dear students? Tell me,
Yes, sir.
Is there any
Yes,
doubt?
sir. No,
So
sir.
okay, so is yeah, Nabila, you want to leave?
Yes, sir.
Okay, beta, you can leave.
Thank you, sir. Bye.
What she is having. Is there any other student who is going to have the iftar timings right now? Because she was living in Dubai, so that's why. Is there anyone who is from Dubai, UAE? No. So let's continue. Okay. So this is the sodium lithium, and this is responsible for the chemical properties. Okay, so if an element is going to have same electron in the outermost shell, then it must have the same chemical properties. So please note it down. The outermost shell's electrons are responsible. Note it down. The outermost shell's electron of an atom is responsible for the chemical property of an element. Please note it down, dear students. Done? Tell me fast.
Yes, sir.
Okay, let's have some questions over it. Which of the following is a chemical change? Which of the following is chemical change? It can have more than one options, or cannot.
1 and 4.
1 and 4.
4.
Or it cannot have, may or may not have. One and 4.
Sir, 2 and 4.
2 and 4. Dilution of acids. Dilution of acid is a chemical change because acids show different. Acid does not show any property without when you are not adding it with the water, because HCl when added to water, it will form H3O positive, that you will learn, and Cl minus. Okay, that you will learn. This is a physical change, evaporation of water, and this is also physical change. Sublimation of camphor crystal. Sublimation means change in the state. Okay, when a substance change, like we have solid camphor. Okay, camphor, and when you heat it, on heating, it directly change, it is solid, and directly change into gas. Camphor gas. So it is no new substance is formed. It is just like converting ice into vapor. So it is still no substances formed. This is physical change. Reaction of quicklime with water. So when quicklime is actually calcium oxide. Okay, when you react it with water, you will learn that you will form calcium hydroxide. Okay, so this reaction. Okay, and this is this reaction. So please note it down. These both are chemical change. Done? Noted?
So why is heat written down? Like,
Heat written down means?
shouldn't heat be written on top of the arrow, or is it fine if you can write it like below it also?
No, you can write it below it off. It's your choice.
Okay.
Heat means heat. Heat is supplied on. If you are just writing on the okay, means arrow represent that the something is given to it. Okay.
No, I thought the catalyst was always on top. That's why.
No, it's not necessary. You can write it at the top also. Okay, tell me the burning of candle. Is it a chemical change or a physical change? Burning of candle. Is there anyone class who can tell me?
Is
Burning
it
of candle.
chemical?
Is it chemical change or a physical change?
Chemical.
It is a chemical as well as physical change. When a candle burns, the two phenomena occurs. Okay. Burning of candles. When we burn a candle, then the two phenomena are shown. Okay. Which are those phenomena? Like you are just burning this candle. Okay. So when you burn it, you will find that on burning, the smoke is being formed. Okay. This smoke is just converting this hydrocarbons into carbon dioxide and water. When you burn this wax, okay, wax plus oxygen, okay, it will gives you carbon dioxide and water. So this is a chemical change. But you know that when candle burns, the wax comes like this and it gets separated. Okay, this is melted wax. Okay, melted wax. Okay, so this melted wax is actually physical change. Okay, so melting of wax is physical change, and burning of wax is chemical change. It is the chemical change. Understood? So when a candle burns, both physical and chemical change take place. Okay. Tell me, which one of the following process involve the chemical reactions or chemical change?
Heating copper wire in presence of air at high temperature.
Okay, heating copper wire. So when you heat something, it just like for example, if you are just heating something like heating water, is it a chemical change or a physical change? Heating water.
Physical.
Hmm? Heating water is a chemical change or a physical change?
Physical.
Physical.
Physical. So why heating of copper is a chemical change?
Rust forms on it.
Yeah, because actually we will simply see here that when copper is heated strongly in the presence of air, then it combined with the oxygen and will form copper oxide, Cu2O. Okay, so and this is brown color, and this because it is black in color. It turns it black. Okay, and it has different properties than this one. So we'll say that this heating of copper wire in the presence of air at high temperature, it is a chemical change. And when you keep the petrol in a China dish, it will get evaporated. And simply we will say that it is a physical change. Liquefaction of air, it is still, you just liquefied it. It's from the gaseous to liquid state. And storing of oxygen gas under a pressure, storing of something is also a physical change. Now you understood?
Yes,
Understood?
sir.
Okay.
Yes, sir.
Let's have some more questions over it. Okay, tell me. Which of the following is chemical and physical change? A is a physical change or a chemical change? A.
Physical.
Physical.
It is physical change. Okay, this one.
Chemical.
Okay, this one.
Physical.
Okay, this one.
Chemical.
Okay, this one.
Physical.
Physical.
Physical. Okay, good. Now you understood. Heating of iron rod to red hot. When iron hot rod is heated, that you will learn when you keep on. Okay, so when you heat it to red hot, so it will actually react with Fe. When react with oxygen, so it will form Fe3O4. Okay, so this is also a chemical change. Okay, got it?
Yes, sir.
Next. All the questions from this chapter on this topic, that chemical change and physical change is over. Now, if I talk about one thing, that when you write this physical change, chemical change in terms of symbols and formula, that we called it chemical change. Okay, like for example, nitrogen gas when burns with in hydrogen gas, so it will gives you ammonia. Ammonia has simple formula. Why not it has formula N2H2? Why they are not combining together? Because you know that nitrogen has 5 electrons in its outermost shell. So 1, 2, 3, 4, 5. We are just making here. Okay. Okay. Now you know that nitrogen has 2,5 electron. It requires 3 electrons to complete its octet. And if we need to make hydrogen is carrier of 1 electron. So it can share only maximum 1 electron. So there will be 3 hydrogen atom will be required with one of its electron. So they will complete their duplet. It will complete its duplet. It will complete its duplet. By sharing. And this nitrogen itself get 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So that's why the formula of ammonia is NH3. Okay. And why do it is N2NH2? Because N2 nitrogen does not exist independently, because nitrogen is a gas and nitrogen has 5 electron and it need to complete its octet. So it exists in the form of like this way, in the form of N2. Nitrogen share 3 electrons with the 2 nitrogen atoms and form N2 molecule. And now it is going to have 6 here and 2 here 8, 6 here and 2 here 8. Similarly, the hydrogen, I have already told you, the 2 hydrogen atoms, they combine together, they complete their duplet. So they exist in the form of N2 and H2. But when they are just forming the compound, they must be written like this in their form. You cannot write the formula of ammonium ion. Like ammonium ion has NH4 positive. Here must be positive sign, that we will learn in the higher classes. Or in this class also, why does this plus indicate and why it is having 4 now instead of 3. So we'll learn it. But now if it is not having any charge, so it means it must have 3 hydrogens, maximum 3 hydrogen. It cannot have N4 or NH2. You cannot have like this without charge. Okay. So it can combine maximum with 3 or minimum with 3. Maximum and minimum exactly. We can say it exactly with 3. So because nitrogen has 2,5, so it required 3 electron. So the 3 electron carrier is only 1 hydrogen atom is can donate maximum 1 electron. So there it means it requires 3 such hydrogen atoms. So it makes NH3. Okay. But you see here that here is 2 nitrogen atoms, 2 hydrogen atoms. And so according to the law of conservation of mass, you study that in the law of conservation of mass, the mass can neither be created nor destroyed. Or the atoms can, we have studied this one in the Dalton atomic theory also, that atoms can neither be created nor destroyed during a chemical reaction. During a chemical reaction, not a nuclear reaction we are not talking about. In the nuclear reaction, Dalton atomic theory does not work. We are just studying the chemical reactions. So in the chemical reactions, atoms are not broken. Atoms, the bond between the two atoms are broken. If their two atoms are combining, the bonds will can be broken, and new bonds are formed. But actual atom is not broken. Like the two hydrogen atoms are combining together. Okay, they are combining together. The bonds between them is broken, but not the actual hydrogen atom is broken. Okay, but in nuclear reaction, actual hydrogen atom is broken. Okay, so we will say that now here, according to Dalton theory, that atoms can neither be created nor destroyed. The total number of atoms on the reactant and the product side must be equal. So we know that we have N2, we have H2. Okay, and the formula for ammonia must be NH3. So how can we balance it? How can we balance it? How can we write it in the proper way that the atoms can neither be created nor destroyed? So we will just balance it. There is a way to balance the chemical equation. So we'll write here 3 here, 3 to the 6 hydrogen. We will learn how to balance, but I'm just writing the balanced chemical equation here. So it is now. Now you see that there are 2 nitrogen atoms. There are 2 nitrogen atoms. They are the 6 hydrogen atoms. They are the 6 hydrogen atom. 2 to the 6. So this 2 is not only going to, this is called stoichiometric coefficient. It is not only going to multiply with nitrogen, it is going to multiply with hydrogen also. So 6 hydrogen, 2 nitrogen, 2 nitrogen. Now it is called balanced chemical equation. What we called it? Balanced chemical equation. So we are always recommended to write the balanced chemical equation when we are writing a chemical equation. If you are not balancing it, like you are writing N2 plus H2 will gives you ammonia and H3. So it will be considered, dear student, it will be considered as a skeleton chemical equation. Is skeleton chemical equation, or we called it unbalanced chemical equation. We can also write it. And if you write this same thing in the words like nitrogen gas, NitroGen, nitrogen gas gas, like this way, nitrogen gas plus hydrogen gives you ammonia, like this arrow ammonia. Okay, like this. So it will be considered as word equations. Okay, word equations. So now you understood? Everybody?
Yes, sir.
So in the
Yes, sir.
next class, we'll be going to learn that how to write the chemical equations. Okay, and the types of chemical equations we might also start, and we